Okay, I might get things underway then. So welcome everybody, and hope you're staying safe and managing to navigate this somewhat difficult time that we're living through at the moment. My name's Simon Dennis, and I'm the director of the Complex Human Data Hub in the Melbourne School of Psychological Sciences, and I'm also the CEO of Unforgettable Research Services. And so this event is an event of Unforgettable Research Services, and will be what I'm hoping to do is to take you through some of the kinds of technologies and so forth that are useful in general for doing experience sampling research, but also to introduce you to some of the services that Unforgettable provides. So firstly, can I just check, is there anyone who's having difficulty hearing me or can't see my screen? If you can indicate. Get the chat up. All good, all good, good. Okay, I think we're good. Okay, so I'll get into it then. So we live in remarkable times. So I think psychological science is going through a period of rapid development at the moment. And I think this really rivals some of the developments that, the kind of major developments that have happened in psychological and behavioural sciences through its history. So in the first instance, I think the kind of first big change that occurred in psychology was the identification of psychology as a science in the first place. And you know, in the broad sweep of history, this didn't happen that long ago. So you know, up until the 1800s, most people thought that the appropriate way to attack psychological problems was more as a kind of philosophical endeavour as opposed to a scientific endeavour. But in the 1800s, we saw this kind of move to believing that there should be lawful relationships in behavioural phenomena, and that we might be able to use the scientific method in order to determine those. Around about the same time, we saw the introduction of mathematics, and so we saw development of psychophysics and the understanding that those lawful relationships could potentially be captured with mathematics. So I would treat that as, even though they happened at kind of the same time, I would treat that as another very significant milestone in the development of psychological science. And then we fast forward a century or more, and we start to see the development of brain scanning technologies, neuroimaging technologies, to really start to give us the first glimpses inside the head. And I think that was also a very substantial and obviously ongoing development in psychological science. But right now, I think we're going through what I would count as two separate revolutions in the way that we understand people's behaviour. So the first of those is illustrated over here, and that's the development of dense, big data sets that allow us to understand the behaviour of individuals. And I think that these kinds of technologies are really significant because for two reasons. One, because they give us far more data to be able to understand what's happening with an individual. And I think one of the things we're starting to understand is that the use of a laboratory paradigm, or the use of a survey, really gives you very much a snapshot of what a person might be thinking or feeling at a particular point in time, but it doesn't give you a lot in which to draw conclusions, and human behaviour is just complex. So I think that's starting to change now, and that's one of the things that I'm really excited about. At the same time, and I think worthy of its own revolution, if you like, is the fact that we're seeing the development of social media and social networks which allows us now to measure the interactions between people on a much larger scale and a more authentic setting as well. And I think that's really crucial as well, because human behaviour clearly is heavily influenced by the people with whom we interact. And so we need to understand that if we're really going to start to understand human psychology. So that's a very exciting kind of broad overview of why I think these kinds of technologies are really interesting. I want to give a slightly more personal perspective about how I think these technologies are going to allow us to really come to understand and have more impact within the world. And so the young lady you see on screen at the moment is my daughter, Sophie. And Sophie is 17 years old now. And about 2 years ago, she started to experience symptoms of lethargy, feeling very tired, undergoing significant mood swings and so forth. And these were, to the extent that it was starting to become a significant impediment to her schooling. And when Sophie was an infant, she was diagnosed with a disease called renal tubular acidosis. And what renal tubular acidosis does is it decreases the ability of the body to reabsorb potassium, and therefore changes the balance of nutrients in the body. And in particular, what it does is it means that potassium gets leached from the bones, which can lead to decreased stature, and also plays havoc with one's appetite and desire for food. So when these kinds of symptoms started to appear, we thought, oh, this is some kind of ongoing consequence of her renal tubular acidosis. So we went to multiple specialists and lots of tests, and couldn't resolve the issue that way. We then thought, she's obviously a young woman, maybe it's something to do with her cycle. So again, we tried multiple tests, multiple interventions that way, still no luck. And then finally I decided, well, I've been advocating using big data. I need to turn this inwards. And so we started tracking Sophie in multiple different ways. So she had a Fitbit, she had a mood app that she was tracking, and we were tracking a number of different other data sources as well. And it quickly became evident that even though Sophie was receiving a significant amount of sleep, the duration of that sleep was significantly impaired. And sorry, the quality of that sleep was significantly impaired. And so we took that to the doctor. The doctor prescribed melatonin, and she's been much better ever since. And so I think this is kind of my personal story about how I think, how the big data has influenced my family. But I think this is going to start to become a much more common kind of practice. And, we need to be thinking about how do we use, all of these big data sources together to come up with really actionable results. And that, I think, will be the entry point for psychology to have much more impact than it has ever had before. I think it'd be fair to say, there are obvious areas where psychology has had significant impact, but overall, given the significance of the subject we study, the impact has not been what one might have anticipated. And I think a big part of that is to do with the data that we've had access to. So what I'm planning to do today is give you an introduction to a number of technologies, and in particular, I'm going to be talking about 4 specific ones. So Unforgettable, which is the one that I'm associated with, IFTTT, SEMA3, and Rescue Time. So I'll go through those first, and I've actually moved Unforgettable down, I just realised. So we'll start with IFTTT. So I just want to kind of very quickly go through those and give you an idea about what they're capable of. to allow you to kind of think about what are the projects that, that I might be interested in doing, and how might these particular technologies potentially be relevant for those projects. And then what I'm going to do is run through a number of example projects that we've been involved in and doing, and just kind of give you a sense of the project, give you a sense of what we were trying to achieve, and tell you a little bit about the technologies that we used and how we used them in order to achieve those objectives. So that's what's coming up. So the first technology that I want to tell you about is IFTTT. So IFTTT stands for if this then that, and what IFTTT does is it's a service which joins services. So so that's so essentially what it does, it takes some kind of data source and it joins it to some other kind of recipient of that data. And it does this for lots and lots of different data streams. So in excess of 600 different data streams that it deals with. And so if you learn nothing else from this webinar, I would want you to take away the thought that IFTTT should be something that you should be investigating. There are other similar services. There's another one called Rapier, for instance. But I think IFTTT is the one that is the most comprehensive. So to give you an idea of some of the kinds of data that IFTTT can give you access to, we'll start up here. And so these are essentially icons representing the different kinds of services that you can connect together. So these ones up here are phone calls and SMSs. And so that can be particularly useful for understanding the way in which people are interacting. And I'll talk later about some work we did with bipolar patients where we used this IFTTT service in order to be able to measure those kinds of interactions that they were having. Another set of kinds of services that IFTTT gives access to are email and calendar services. So, for instance, with the calendar services, we're currently engaged in an exercise, in a study where we're looking at how it is that people divide the world up into contexts, essentially, and we're using the calendars from multiple different services as one source of evidence about where those context boundaries are. And so from that, we're then going to use other sources to start to try to predict from people's data when they're switching contexts. So, so that's a useful thing. The email has been a useful thing in the past. Just recently, Google has started to clamp down on the use of these kinds of technologies. And so the email stream has recently been taken away. And so in Unforgettable, we've come up with workarounds. So we don't actually use IFTTT for that any longer. But there are other email services that IFTTT can give you. As I said, there are lots and lots of different data streams that IFTTT can give. Some other ones that you may not think of as data streams, but ones which are available and could potentially be useful are things like ESPN, Time Magazine, NPR, the National Public Radio in the US, and so forth. So what these services give you is a sense of what's happening on a global scale at any given time. And so in Unforgettable, we've used NPR, for instance, to help people to be able to remember different events. So, so they have personal events. Those personal events get tied to more global events. And so if they're able to know when those global events occurred, that can sometimes help them to remember personal events as well. More generally, you might imagine that for different people at different times, what's happening in certain sports or what's happening in the political sphere may impact things like their emotions, their ability to cope, and so forth. And so I think there's a lot of data that can come from those kinds of sources, which we haven't really exploited in the past. Another kind of class of data sources are the wearables. So there's Fitbit, Strava, this is Android Gear, this is the Nike wearable system. So the I'll talk later about some work we've done using Fitbit, but all of these sources are available and obviously useful. So the amount of mobility people are experiencing can be a very useful kind of data set to have. Mobility influences all kinds of psychological processes, and also sleep. So Fitbit gives you a window into sleep, and I'll talk more about that later. So that's kind of personal devices. There are also IFTTT connections to lots of Internet of Things devices. Washing machines, dryers, refrigerators have all been, these are kind of the more sophisticated ones, of course, have all been connected. Probably not enough of those in general circulation to get a lot of data that way, but certainly in the future, I think that's going to be really crucial. So if you're interested in eating behaviours, for instance, then knowing when people are accessing their fridge could be really useful. Sorry about that. The cars are also being instrumented. Again, if you're interested in, for instance, sustainability practices, then being able to link people's data from their cars, what trips they're taking, how fast they're going, and so forth, is, I think, potentially useful information. And then, of course, the other big source are the social media forms. So we've got Tumblr, Facebook, Twitter, Pinterest, and Instagram there. And there are a series of other ones that you can get through IFTT as well. So it's, and obviously, they give you kind of generated information that about how people are feeling, what they're thinking about at any given time. So again, all of those sources are particularly useful. One thing I forgot to say is that I forgot to introduce Michael and Ben. Guys, can you just put your webcams on just for a second? Okay, so I was going to say Ben is the one with the beard, but I guess they both have beards now. Michael and Ben are going to be in the chat. So if you have any questions as I'm going along, feel free to ask those, and Michael and Ben will be there to answer those. Thanks, guys.
Thanks, Matt.
Okay, so that's IFTTT, and as I said, if you don't take anything else away from this webinar, take away that IFTTT is a really useful tool and something that you should think about. Now, another key element of data that we want to be able to use is ecological momentary assessment data. So for those who aren't aware, this is data which is where you actually query people at regular intervals during their lives in order to ascertain how they're feeling or what they are thinking or what's occurring, what's their context at specific times. And so we've been doing it. There are multiple apps available that allow you to do this. We've been using one called SEMA3, which was developed by Pete Cavell and others, which gives you quite a bit of control. So it allows you to set up a schedule. You can set up multiple different elements within these kind of micro surveys, and you can deliver those multiple times a day. And again, I'll talk about a project where we've used SEMA3, where we were looking at people's emotions, and we queried them 8 times a day to get a sense of how they were feeling. and then tied that to human memory. So, so SEMA3 is a really useful tool if you want to be able to get at that kind of daily experience that people have. Another one that we've just started to use recently is called Rescue Time. You can use Rescue Time through IFTTT, but I've kind of highlighted it because Rescue Time gives you a capability where you can look at people's time use over days, weeks, and months. So what it does is it looks at all of the different apps, websites, and so forth that you're interacting with. And it does that. The real strength of it is that it does that across platforms. So it does it on your desktop, it does it on your tablet, and it does it on your phone. And it combines all of that together to give a sense of how much time people are spending on different kinds of activities. So this is actually a screenshot. At the bottom is a screenshot from my Rescue Time at was about 2 o'clock yesterday. And so you can see there it's identified that I've spent about a bit over 50% of my time in communication and scheduling. And so that's occurring because I do a lot of Zooming. But I'm also doing some other things. So it's got social networking time there and so forth. So it gives you this kind of broad overview of how people are dividing up their days. And that can be really useful information. You can also look down at a more fine-grained level to see, exactly which of these different apps, which different websites people have been using, which different applications people have been using as well. So we started using this with Isabel Krug in an eating disorders study, and I'm looking forward to seeing how the data comes out for that one, because I think Rescue Time could be a really useful tool. And then finally, we come to Unforgettable, which is the service that we provide. So Unforgettable is an app, but it's also a set of online research services. And so the app allows you to collect GPS accelerometry, a kind of obfuscated form of audio, and then images if you so choose. By default, images are off, but you can ask them to be turned on. And I'll talk about a study that we did where we used images. What we've been really focused on with Unforgettable is figuring out how to be able to collect these kinds of data sources, which are very sensitive data sources. Knowing where people are and what kinds of activities they're involved in and so forth, and what they might be hearing. That's all low level and very sensitive data. So what we've been doing is really working hard to figure out how to make sure that people have control over what's going on with their data. And so we have multiple mechanisms. We have the capacity for people to turn all of the different streams on and off very obviously. We have the capacity for them to delete data before it leaves the phone, as well as after it leaves the phone. And again, one of the things you learn when you start to do this work, and we've been doing this work for over a decade now, is that battery life becomes a really fundamental issue. And so we've got various mechanisms in there that allow us to optimize the life of the battery on different phones. So, but these kinds of data sources can be extremely useful. And again, I'll talk more about how we've used some of these shortly. To give you a sense, the raw data can be quite useful, and we certainly use that. But what can be even more useful is once you use that raw data in order to understand more about the nature of the context in which people are situated at any given time. So for instance, the Unforgettable system augments the kind of raw data that's created with things like place types. So are they in a restaurant? Are they in a church? Is it a fast food kind of location? Things like that. So that kind of helps you to understand the context better. It gives you addresses. It tells you what the weather was like at any given time. And we also have a set of machine learning classifiers that are in there. So you can see here this little voice tag. So what that's doing is it's taking that kind of raw audio, that kind of obfuscated audio that we create, that we record, and it runs that through a machine learning classifier. So it can say, is there voice in this sample? And so that tells you things, gives you information about people's social interaction, for instance, to what extent are they talking to people, and so forth. It also will classify things like traffic, so you can tell, how much time they're spending, say, in the car and so forth. So, so it kind of takes it from, this kind of raw, difficult to interpret data up to a level where you can start to form hypotheses about what might be going on. The Unforgettable system also gives you this search interface. So what you're seeing here is what happens when I type in Princeton. And so when I do that, it goes through, it searches all of the data. So I've been collecting for well over 4 years now. And comes back with the events that are related to Princeton. So this first one was a time period where I did a search for Princeton. And this second event down here is a point where I was in Princeton. And so you can see here an image. So it goes through and gets the street view images of that, of where I was, and gives the address and so forth, and identifies that this was a place of lodging. So this was actually the hotel that I was staying in Princeton. It was overcast on this particular day and so forth. So lots of additional information. So this is kind of useful for participants. There's some reason for them to want to interact with the system. But all of that information is also available to researchers. You'll notice up here, there's a little cross. So that is available so that users can delete data segments that they don't necessarily want you to have. Now that's not good for research purposes, of course, but it is good in terms of maintaining a strong relationship with your participants, which with this kind of data is really crucial. And then the other thing, I haven't gone through these here, but we have a whole series of visualization tools that allow you to get a sense and allow the participants to get a sense of what's happening in their lives more generally too. So, so that kind of gives you an overview of of 4, what I would say, critical technologies. There are, of course, huge numbers of other technologies that are available, and they, the space is kind of enormous. But I think these ones give you really quite a broad set of capabilities without, within a relatively small set of technologies. And so, so I think they're a good point if you're getting started in this kind of area, to kind of focus on these ones and look at what capabilities they give you. So what I want to change gears now and just start talking about a few projects and give you a sense of some of the things that we've done. And I'm hoping this will, by kind of making it a bit more concrete, will help you to think about, well, how could I use some of these data sources in the kinds of research that I'm involved in? So the first one that I want to talk about is a project. So I should say my area of expertise is memory. And so a lot of these examples are going to be memory-based examples. And this first one is focused around memory for where. So how is it that people remember where they were at a given time? So in this case, we use the Unforgettable app, and we were particularly focused on GPS, obviously. So it's memory for where, so you need to know where people were, the obfuscated audio, and accelerometry. And the other key researchers on this project were Elizabeth Laliberté and Hyung Wook Yim. For each of these projects, I've given given either a web address down here to a blog or the citation, so that you can research or take a look at, get more details later if you're interested. So this project was kind of motivated by a story that has been kind of highlighted within the memory literature of a person called Ronald Cotton. So Cotton was exonerated in 1995 for after spending 10 years in prison for crimes he didn't commit. And so the focus, so this was a rape and burglary that he was accused of, and the Jennifer Thompson Canino, who's standing next to him here, was the victim. And but it wasn't Cotton that actually committed the crime. Now, in the memory literature, this is a well-known case because not only did Thompson Canino identify Cotton in an original lineup and both a photo lineup and then a in-person lineup, but 2 years after the Cotton was convicted, the real rapist, Bobby Poole, was brought into a courtroom along with Cotton, and so she had the real rapist and Cotton side by side, and she chose Cotton again. And so this was is kind of used as an example of some of the frailness of eyewitness testimony. However, there's another key aspect about this case, and that's that Cotton gave a false alibi. So instead of saying where he was at the time of the crime, he actually said where he was the week before. And so he misremembered, but of course the fact that he gave it a false alibi kind of increased the certainty that the jury had that he was the actual culprit. And so we were kind of interested in, okay, well, how do people go about making this decision about where they were? So we had 57 participants go out. They collected data for a month using the Unforgettable app. And so they collected GPS coordinates every 10 minutes. So that gave us a bit over 8,500 pairs of GPS coordinates per subject. They collected accelerometry vectors approximately every 10 times a second. So that gives us about 51 million data points per subject. And then they collected audio as 3-second segments of these, what we call mill frequency cepstral coefficients every 10 minutes. So with the audio, what we're doing is we're making sure the segments are short. They're in this format which doesn't allow or doesn't facilitate the recording or the playback of the segments. So it makes it very hard for you to reconstruct people's conversations from these segments. So the participants collected for a month. There was a 1 week retention interval, and then they received a memory test. And the memory test looked like this. So we would say, where were you Thursday morning, 8 a.m. on August 15th? They'd be given 4 alternatives, and they had to decide which of those 4 alternatives was the correct one. So the first interesting point from this is they were accurate about 64% of the time. Of course, that means they were wrong about 1/3 of the time, and so that gives you a bit of a sense about the fact that if people were in the situation that Cotton was in, the likelihood of an error is actually reasonably high. So that's interesting. But the other thing we were able to do is we were able to use a conditional logit model in order to say, well, what is it that makes people make these errors? So each of the pins had a set of data. So it had the GPS, it had audio, and it had location data. And so we were able to say, well, how far away was the was that pin, the location identified by that pin, from the true location. How far away in audio space, how similar was it in, to each of the pins or each of the experiences to the correct one in that space? How close was it? Sorry, that shouldn't be location, that should be movement. So in movement space, in terms of what were they doing at the time, how close was it for each of these different things? And so we can use that to get a sense of, in the conditional logit model, to get a sense of which of these things really matter for people's memories. And so lo and behold, GPS, the location really matters. The other modalities, the audio and the accelerometry, much less so, although all significant. So these are 95% credible intervals around beta weights for our conditional logit model. And you can see they all exclude 0. So GPS is certainly by far the most important, but these other things, the nature of the activity they're involved in, what they're hearing, have some impact as well. We also looked at that kind of categorical time question. So I said that Cotton misremembered exactly a week out. And so the question is, well, how likely is that? So again, we used a conditional logit model. Now, instead of continuous time, we looked at kind of categorical time. So how, you know, if I code as this is the same hour from the day before, or this is the same day from the week before, how important are those predictors? And you can see there's very substantial effects there. So that kind of error that Cotton made is extremely common kind of error. And then another key one is people saying the right hour but the wrong day. So that kind of gives you an idea about how we can use some of these data sources to get a sense of the how context influences people's behaviour. So in this case, it's people's memories, but obviously that contextual information can be used to predict lots of other kinds of phenomena as well. I think in memory, it's a particularly useful kind of data to have, because, you know, really what we want to know about as memory scientists is how do people remember these things in their everyday lives. And, you know, it's always been a bit of a stretch to believe that what we do in the laboratory is telling us a whole lot about what happens in people's lives. So, you know, these things like the categorical time, how would we, you know, how would you realistically study that in a laboratory situation? It'd be pretty difficult. But by using these kinds of technologies, we can get at those kinds of phenomena. So, just check the time. Okay, I'm going to whiz through this one and then probably skip the next one and try to get on to the last example. So in this study, again, it was a memory for wear paradigm. So same kind of experiment as before, as the first one. But this time we used ecological momentary assessment. So we used the CEMA3 app, and we asked people about their emotions at different times. So now we have their ratings of discrete emotions. So these were things like how happy are you, how sad are you, how angry are you, how content are you, how relaxed are you, and so forth. And so we had those ratings that were derived from micro surveys using the CEMA3 app. But of course, we also had their GPS, we also had their auditory, and we also had their accelerometry. So we're able to combine across these different data sources in order to understand more than we could with any one in particular. And so as I mentioned, we use the CEMA3 app, so that's what it looks like there. And they have just had to make these ratings in these discrete emotions. So again, we use one of those, the conditional logit model. And you can see here, so these are the discrete emotions and again, the 95% credible intervals around the beta weights in the logistic regression model. And you can see that all of the emotions, so now just to be clear, what this is saying is to what degree is the similarity between how I was feeling at the actual time, how is that similarity to how I felt at another time and place? How is that impacting the likelihood that I'll make an error? So this is not saying happiness means I make better judgments. This is saying how much is happiness a part of the content of the memory that people encode. And so you can see here that all of the emotions have very substantial effects. And these are in terms of memory science, right? We never see effects of these kinds of magnitudes typically. So, and I think that's testament to how much more information these data sources are giving us. But you can see all of those emotions have very substantial effects. We then switched to a logistic regression model, and now we combine different emotions. And now this is probably what you would have, most people would have thought of in the first instance, is how does emotion affect the accuracy of my response? And so, number of things that are interesting about this. So the first one is that the negative emotions didn't show effects where the positive emotions did. And so that's a complete contrast to what we typically see in the laboratory, where the negative emotions typically do show effects, the positive emotions don't, or at least the effects are mixed with positive emotions. But the other thing that was very curious about this is that you can see that the low intensity positive emotions like content and relaxed were positively related to people's ability to say where they were at a given time. But high arousal positive emotions like excited, they're negatively related to people's ability to remember where they were at a given time. So that's really curious, because you might have thought that a higher arousal event, being excited, being very happy, that you might have thought that would be more salient in people's memories, that they might encode better, and that might help them to remember those events. But that's not the case, or at least in this study, it wasn't the case. So, so now that I think what that demonstrates is the way you can bring these different data sources, the ecological momentary assessment, to get at psychological constructs that are not straightforward to assess via passive means, but then you can combine them with other data sources that are easily accessible by passive means in order to come together to form conclusions. Yeah, I'm starting to run out of time, so I'm just going to skip over this example, but this was a case where we used neuroimaging alongside experience sampling to get the kind of what's happening in the environment, what's happening in the brain. So it's kind of what's outside the brain, what's inside the brain, in order to identify where people are coding their memories for when and where. And so to cut a long story short, it's this left anterior region, but I'm going to allow that one to go through for questions. The final one I wanted to talk about was a project that we've been doing for a while now on bipolar spectrum disorder. And in some sense, I think this project is probably exemplifies what I think we ought to be aiming for in terms of trying to bring many different sources of data together, probably better than anything else that we've done. So in this project, we are working with bipolar patients, and we use multiple different streams. So we had Fitbit sleep, we had phone calls, we had SMSs, we had GPS, we had accelerometry, and we were also doing a weekly EMA survey. So, so lots of different data sources that we can bring together. Now, one of the advantages of using these kinds of passive technologies, in particular with in these patient populations, is that it's often the case that compliance with other kinds of measures is fairly poor, particularly if you try to do this over a longer time period. And that's certainly the case with bipolar patients. So they struggle. The self-report measures are subjective. They tend to overrate their positive behaviours, underrate their negative behaviours. But also people with bipolar are unwell, and so at various different times they're unwell to different degrees. So they struggle with motivation, they struggle with memory, they struggle with executive functioning, and they struggle with coordination. So all of that makes it really useful to have some forms of passive data. So we collected a large amount of data. So we used a whole set of standard measures. So we used the SCID for diagnosis. We had a couple of mood measures, a couple of physical activity, or a physical activity measure, a sleep measure, and a social support measure. So these are all standardized tools. And I think this is one of the things that we're going to be doing over the next kind of 5 to 10 years, is starting to really understand what's the relationship between all of these passive and active experience sampling measures and the more traditional scales that we've created. So very quickly, we looked at sleep, and so interesting thing here was that Fitbit's sleep measures did a good job of capturing the duration of sleep as measured by a standard PSQI survey, but they were very disparate in terms of the disturbances and the efficiency of the sleep. And my suspicion here is that that's a problem with the PSQI, not a problem with the Fitbit. So I just think that people are particularly poor at being able to self-report when they've had bad sleep. And then overall, we found an increase in sleep disturbances was correlated with depressive states. Lots of additional work to be done there, but an indicator of what can be done. We also looked at physical activity. So there we found increased levels of physical activity predicted mild or severe elevated mood states. Decreased levels were marginally predictive of depressed states. So I guess pretty much as one might expect, but good to see that it kind of matches with people's, the kind of face validity seems reasonable. And then social interaction. So we used the SMSs, the phone calls, and also mobility. So how much time were people's, or how far were people moving on each day as an indicator of how much social interaction they might have, as well as that voice tag. So to what extent, how often were they hearing other people's voices? And again, these are kind of perhaps predictable, but it's comforting to know these things work in the ways you would expect. So depressive episodes are associated with increased number of incoming and outgoing SMSs. So people get depressed, people get worried about them, and so they start trying to interact with them. And the manic episodes are associated with an increased number of unique contacts and increased mobility. So again, the kinds of things you might anticipate. So to kind of start the conclusion, so we've got hopefully what I've done is convinced you that these kinds of data sources are really useful, and I think are going to be an ever-increasing aspect of the way we go about doing psychological science. Not that we're going to stop doing surveys and stop doing laboratory experiments, but I think this is going, as a proportion, this is going to become more and more significant as time goes by. But it requires a significant infrastructure, technical infrastructure, to make it happen. And so you have to get your head around a whole set of new technologies in order to be able to deal with this kind of data. as I mentioned, most of the projects today tend to focus on one kind of data source. So, it's quite common, for instance, to see people do an EMA study where all they do is the EMA study. But I think what's going to happen is we're going to start doing studies where we're getting many more of these sources all happening simultaneously and kind of triangulating on a conclusion from these multiple sources, seeing which sources are most useful for measuring which constructs and so forth. However, accumulating the data at scale is expensive and time consuming. And the other thing you have to worry about is the privacy concerns, because they're much more significant with this kind of data than they are with typical data. So at Unforgettable, we've been working on that. So we have a research participant pool, over 2,700 people now who are collecting data continually. And so, if you want, the last 2 months of data, or, data for the last year or something like that, there are people in there who have been collecting. So you don't kind of have to wait for the year in order for to find out what their data might look like. However, the privacy considerations lead us to some different trade-offs in terms of the ownership of data. So because of the nature of this data, because it's going to get used potentially many times over, we actually have participants retain ownership of their data. And so then if you do a project on our platform, then you come in, you register the project, so that then goes out to the participant pool as it would on Mechanical Turk or Prolific Academic. But then people consent, they come into the project, but you're allowed to use their data, but you don't gain, you don't then have ownership of that data. They retain ownership of the data. We've worked very hard on a privacy sensitive data ecosystem. In 2 weeks' time, I'm going to be giving another webinar where we talk specifically about how we do that, because we've spent a lot of time thinking about how to do this the right way, because the current mechanisms we have using languages like R and MATLAB and Python for doing this kind of data analysis really aren't good enough. And so we've been working on better approaches. And and then the company also does consulting. So there's a lot of issues. Obviously, getting ethics for these kinds of studies can be difficult. We've done this in multiple different universities now, and we can advise people on that. Choosing the technologies, we can advise on that. And then how you go about doing data analysis with these kinds of data sets, we can advise on as well. Might just skip over that. So I guess just the key point here is the way that we charge is per $10 US per subject month of data, and then whatever you pay subjects. So that's the kind of model that we work under in Unforgettable. As I mentioned, I'm going to be giving another webinar in a couple of weeks' time. Looks like I've got the wrong image there. So this will be happening in 2 weeks' time. It's going to be focused around the private language, which is our answer to how do you do privacy preserving data analysis. So if you're interested in hearing about that one, then feel free to come along to that webinar. We're also running a special offer at the moment. So if you're interested in trying out something where we're giving a waiver of $100 worth, so it's about 10 participants for a sample project. That's, just to be clear, that's a waiver of the Unforgettable fees. That's not a waiver of whatever you pay the subjects. But that's available to anyone at the moment who'd like to just put their toe in the water and see how this kind of stuff might work. And we're also available for consultations and demonstrations. So if you would like to talk to us now, Ben and Michael and myself are going to be available to chat, and we can break out into breakout rooms if people want to do that. Or you can sign up for an online demonstration or consultation at unforgettable.me/ research services. Okay, so that's it from me for now. Let's see, what's the timing? Okay, so it looks like that's about time as well. Happy to answer questions, but what we might do is allow anyone who needs to go, and then those who would like to stay around and do a bit more question and answer, then feel free to do so, and we're going to be here. So thanks all. So for those who would like to stay around, can I get you just to indicate in chat if you're interested in talking about specific projects or not? Okay, well, maybe what I might do before we talk to any individuals, are there any general questions that people have that they would like me to address? So maybe if you type those into the chat, and then I can talk about those. Okay, so Chad has asked about what I didn't like about Python for big data analysis. So and you know, this applies to all of the standard languages like MATLAB and R as well. So the fundamental problem is that there's no way for you to protect the data. So the kind of underlying assumption for all of the data analysis languages and all of the data analysis packages at this point is that the researcher should have direct access to the data. And so, you know, when that's not sensitive data, there's no problem with that. But when it's sensitive data, the difficulty you get into is that you really just are relying on the kind of goodwill of the researcher. And for the most part, that works out. But you know, there's obviously key examples where that hasn't worked out, and the most obvious one is Cambridge Analytica. So there, Alexander Kogan, who was the researcher, you know, was a legitimate researcher. He had he didn't hack into the system or anything like that. He was an associate of Cambridge University. So, you know, looked like there was no reason to think that that there should be any problem. And nonetheless, he, you know, leaked 87 million records to Cambridge Analytica ultimately. And you know, we'll never know probably to what extent that really impacted the US election, but there was certainly an effort made to influence the US election using that data. So, and I think that's a fundamental problem. You know, you can put whatever legal constraints you like around people and so forth, and you can set up ethics boards and indicate, you know, inform people and tutor people on how they should deal with data, but you can never guarantee that data is not going to be moved. and potentially to places where you don't want it to be moved. And, you know, when one legitimate researcher gives it to another person they think is legitimate, who gives it to another person who's maybe just a little bit less legitimate. And, you know, it's the nature of data that once you start copying it, there's no real way to control it. And really R and MATLAB and Python, none of these give you any ability to protect the data from the researcher. And so what we've been doing is developing this new language called private, which creates that separation. So you code up your model in private, and before you actually get to see the results, so you don't get direct access to the underlying data at all. And then before you get to see the results of those analyses, it goes through and does a sensitivity analysis. So it essentially runs each of your analysis with each person removed to see whether the result is too sensitive to any given individual. And all of that's baked into the language. So there's no way to circumvent that. So yeah, so that's so I use Python all the time. I love Python as a language in general, but I don't think it's the future for sensitive data. Okay, so Steve, I see, is asking about the metrics for distance similarity in sound movement, etc. spaces. Seems like there might be a few plausible choices, maybe with different trade-offs. Yeah, absolutely. So, so firstly, good to hear from you, Steve. So absolutely, there are many trade-offs. So, and they're all, you know, tend to be specific to the data stream that you're dealing with. So in the image space is probably where we're most developed. And so there, what we've done is we've tried out multiple different kinds of representations. So I didn't get to talk very much about this, but this was something that we used in the neural work. And so there, we've tried things like color histograms, what are called color correlograms, SIFT representations, GIST representations, and so forth. And so what we've done is we've just essentially looked at some other kinds of measures. So probably don't have a time to go into it now, but there's something called a recurrence plot, which allows you to get a sense of the context of life. And we compare what these plots look like across these different kinds of computational mechanisms. And so there, what we've kind of decided is generally best is this color correlogram. With the other kinds of streams, so we use for GPS, we've tended to use location, just like the GPS coordinates themselves, and just do Euclidean distances between those GPS coordinates. My suspicion is that that's not quite right, that as we saw with time, the psychological space that we're really dealing with GPS is not faithful to the physical space. And we might, we haven't done these comparisons yet, but we might end up finding that we'd be better off just saying, this is a location, this is a location, this is a location, and you're either in that location or you're not in that location. So, as I said before, we've done that with time, and indeed it seemed like dividing that up categorically into weeks and days and hours, as opposed to how much actual continuous time was between two events, seems to work best. With the audio data, we use the Mel frequency Kepstrel coefficients. They've already been set up to try to mimic the human auditory system. So a Mel frequency Kepstrel coefficient it's like a fast Fourier transform, except instead of the bins being equal, the bins have different sizes, and those are designed to capture the different ways in which the way that this kind of logarithmic scaling that you see in the human auditory system. So yeah, so we've got some ideas on that, but I guess I would freely admit that there's still a long way to go before we can be sure that the way we're doing the analysis faithfully captures these underlying psychological spaces that are relevant. Okay. So are there any other questions that people have? Okay then, so what I might do, if there isn't anyone who wants to have a specific consultation now, what I might do is just point you towards let me do this, towards, if I can make that work, go up. Yeah, to the unforgettable.me research services page. So there's a place that you can put your details in and give a little description of what you might be interested in. So maybe as you digest more, there might be opportunity that you may want to contact us again. And so that would be the place to do that. So otherwise, I might finish here and say thank you very much for coming, and hope to talk to at least some of you in the future. Bye for now.